All right, guys, reactions of metal ions in aqueous solution. By the end of this video, you're going to know every single color change observation and equation you need to know for this topic under AQA A Level chemistry. Okay, so what exactly do we need to know? This is straight out of the specification. You need to know the observations and the equations for the simple test tube reactions of the following ions with the bases OH-, so hydroxide, NH3, and carbonate. So NH3 is ammonia. Now there's two oxidation state charges of these metal ions, okay? You're going to have 2+ and 3+. Now AQA have made this pretty easy for us, and there's only two different metal ions for each, okay? So for the 2+ charge ions, you have iron and copper, and then for the 3+, you have aluminium and iron. Okay, so let's start with the 4 aqueous ions you need to know. These are going to be in the form of hexa-aqua complexes, okay? And we're going to look at what colors they have to begin with. These are all going to be solutions, okay? If something is aqueous, it's a solution. So let's look at the 4 that we're dealing with and look at the equations that occur and the color changes. So let's look at copper 2+ to begin with. Okay, so you're always going to have this same format where you have the metal right here, then you're going to have 6 water molecules. These are the ligands, square brackets to denote a complex, and then the charge of the central metal ion at the top right. Okay, now this can change, this charge right here, if you're dealing with a negative ion, for example, a chloride ion, this is going to change the overall charge on the complex. But for the sake of this, we're only dealing with starting water molecules, okay, and these are all neutral, so we're completely fine here. So this will give away what the charge on the central metal ion is to begin with. All right, guys, so I've drawn our 4 different complexes out, our hexa-aqua complexes. What are the starting solution colors? So for copper 2+ right here, this is a blue solution. Okay, what is our iron 2+? This is a green solution. Okay, what is our iron 3+? This is a purple or violet solution. The 4th one here, aluminium 3+, this is a colorless solution. Okay, I'm going to use black here because I don't have a colorless pen color, but hopefully that's all good for you guys. Now we've done the colors, let's look at the equations that occurs. First off, I'm going to look at when we react with hydroxide and ammonia. Okay, these are the first bases that we're going to look at, and then we'll move on to the carbonates afterwards. So let's start with copper here. When we're reacting it with a hydroxide, you just literally just do plus OH- here to signify the hydroxide ion. Now in questions for AQA, you're normally going to be reacting with sodium hydroxide, so just keep that in mind, but we're only dealing with the ionic hydroxide portion of this compound, okay? So it's real simple here. Now, something you want to keep in mind that makes these equations so much easier to remember is whatever the charge is on the metal ion. So for example, with this copper, it's 2+, you just chuck a mole coefficient of that charge in front of the hydroxide ion. Okay, and it's exactly the same for ammonia, which we'll look at afterwards. But just remember that tip and it will save you quite a lot of time and you won't have to be super stressed out remembering all the different equations. So what does this form then? This is going to form a precipitate, okay? And this precipitate involves 4 water molecules and 2 hydroxide molecules. Okay, and this is a solid. You have to show this as a solid. And that's something I've actually left out. So all of these hexa-aqua complexes here are aqueous. Okay, and when they react with the hydroxide or the ammonia, these are also going to be aqueous, so just keep that in mind. Both of our reactants here are aqueous, whereas we're going to have a solid precipitate product forming. What is our other product? We get 2 water molecules kicked off, so I'm just going to write that right here, 2H2O, and this is a liquid, okay, just lowercase l right here. Okay, so I've drawn out our iron 2+ equation as well. As you can see here, these are exactly the same. All you have to do is swap out what the metal ion is, okay? Now, these first 2 color changes are super easy. So as I mentioned, our starting solution is blue for the copper and green for the iron, right? Super easy one here. This forms a blue precipitate and a green precipitate respectively. Okay, so these first two ones are super easy. You just have to remember the exact same color, but they just form a precipitate rather than remaining as a solution. Okay, so let's quickly move on to our 3+ ions here. Now, I'm not going to spend too much time explaining things here, but just remember my tip from before. If it's a 3+ ion, how many moles of a hydroxide are we going to be reacting with? 3. Okay, simple as that. So both of these, for the iron and the aluminium, is going to be 3 OH minus. And the main difference here for these two 3+ ions is instead of it being 4 molecules of H2O and 2 OH minuses or 2 hydroxide right here, it's going to be 3 of each. Okay, so it's going to be Fe, H2O 3, and then OH 3. Okay, and again, this is a precipitate, so really keep that change in state in mind. All right, so what is our color change going to be? As I said, iron 3+, this is originally a violet or a purple solution. So I'm just going to put purple here, but violet is also fine. And what is this going to form? It's going to form a precipitate again, as we can see with this solid state symbol, but it's going to be brown, okay? Brown precipitate. Okay, just keep that in mind, goes from purple to brown. Next up was our aluminium. So this started with a colorless solution, and this actually forms a white precipitate. So I'm going to write that out in gray, but just remember white precipitate, okay? So we've looked at what occurs when you react with a hydroxide. You also need to know ammonia, okay? And this is super simple. What we're going to do here is you keep the mole coefficients the same, but literally just swap it out with NH3. The product right here, this first row of products is exactly the same, but the water molecule is going to be changed for an ammonium ion, so an NH4+. I'll write that out quickly, and this has to change to aqueous, okay? The state symbol is no longer an L or a liquid for water, it's going to be aqueous for the ammonium ion, okay? Okay, so I've written it all out, and you can see here that the mole coefficients stay the same, 2 for a 2+, 3 for a 3+, and then we're going to get ammonium ion aqueous forming here instead of water. Now the precipitates that are formed exactly the same, and the colors are exactly the same, so you don't need to worry about that. Now, a little bit of extra information here. If they ask you what type of reaction this is, it's going to be an acid-base reaction. Now, in A-level chemistry, you have two different types of acids and bases. You're going to have a Bronsted-Lowry acid base or a Lewis acid base. And these are Bronsted-Lowry acid base reactions or deprotonation acid base reactions. As you can see here, this ammonia molecule, as well as the hydroxide ion, gains a proton from this water ligand right here. Okay, so what happens is this acts as a base, accepts a proton from the water ligand, which ultimately acts as an acid, and it's deprotonated right here, which you can see that is left with an OH instead of a H2O. Okay, so a little bit of extra information there. Hopefully that helps you guys out. Okay, something that can really trip students up is when they ask for excess hydroxide or ammonia, okay? Now the color changes and the equations that I just run through, these are specifically for limited amounts of hydroxide and ammonia. Now AQA is not always explicitly clear with this. They may just say add sodium hydroxide or something like this. They may not say limited amounts. Whereas if they say excess, this is explicitly clear that an excess amount of the reagent has been added. So just keep these slight caveats in mind. Now there's two we need to be aware of. For excess hydroxide ions, we're going to be dealing with aluminium 3+, more specifically the product precipitate once it's already been reacted with the hydroxide, and then a copper 2+ precipitate once it's reacted with ammonia. And I'll go through these right now. So cast your mind back to the previous equation and think to yourself, What was the aluminium 3 plus precipitate that was formed when reacting with a hydroxide? Okay, so it was aluminium H2O3, OH3. Remember, the state of this is solid. Okay, and when we react with excess hydroxide, you simply add 1 more mole of hydroxide like this, and this is going to be aqueous. Okay, and we're actually going to form a complex here. What is our complex going to be? It's going to be aluminium, OH, 4 of these guys, and we're going to have a 1 minus charge. Remember earlier I said when we're adding in negative ions, for example, like a chloride ion or an OH minus ion, this is going to alter the overall charge on the complex, okay? So we've got 1 aluminium 3 plus right here, and then we've got 4 lots of OH minus. So that's minus 4 right here. And this gives us an overall charge of -1. So just keep that in mind. So what is the state on this complex is going to be aqueous. Okay, all complexes are aqueous. Just try and remember that. And then we're going to have 3 water molecules kicked off. Okay, and this is a liquid right here. So what is the observation going to be here? It's going to be this precipitate right here. What color was this precipitate? Do you remember? It was white, okay? White precipitate. And the observation is that this white precipitate dissolves to become a colorless solution again, okay? Even though it's a different starting complex, this isn't our hexa aqua complex, it's still a colorless solution. So I'll write that right here, colorless solution, okay? Now, a little piece of extra information that you really need to be aware of that they can chuck in for like a quick 1-2 mark question is the fact that this right here is amphoteric. What does amphoteric mean? Let's break this down. Some of you may already know. It simply means that it can react and dissolve in both acids and bases, all right? Okay, just remember that. This right here can react with both acids and bases. So what's the equation you need to know for if it reacts with an acid instead of a hydroxide? They may ask you this, okay? So it's going to be our starting reactant, exactly the same. Now, instead of reacting with 1 mole of hydroxide ions, we're going to react with 3 moles of protons. So from an acid right here. And this is going to be aqueous. It's going to be a solution of acid. And this is going to form, what is it going to form? Hexa aqua complex. Okay, we're going back to our starting reactant, H2O6, 3 plus. And this is aqueous, okay? Hexa aqua complex right here. So we're going from a white precipitate to a colorless solution. So you're going to get the same observation each time, but just keep in mind the change in the other reactant right here for these 2 equations. And remember the keyword amphoteric, okay? Right, that's aluminium 3 plus out of the way. Let's look at copper, okay? So when we're reacting copper with an excess reagent, you don't need to know about hydroxide in excess, but you do need to know ammonia in excess, okay? So if we write out our starting precipitate right here, OH2, and this is a solid. What do we react this with? We react it with an excess of ammonia. And this one's kind of one you just have to remember. You're not going to be dealing with 2 moles of ammonia for the 2 plus copper ion. We're dealing with 4 moles of ammonia. Okay, and this is aqueous. Just try and remember that. What is our product going to be? Now we're going to have a complex forming, okay? I'll go through that complex in a second, and you're going to have 2 other products, okay? So our complex is going to be a copper 2 plus, and it's going to have 4 ammonia ligands and 2 water ligands. Okay, 2 plus charge, still the same because ammonia and water are neutral, so it doesn't affect the overall charge. This is going to be aqueous. Remember, all complexes are aqueous. We're going to have 2 moles of water, liquid, and 2 moles of hydroxide aqueous. Okay, as we can see here, 2 moles of water were kicked off and we're only left with 2 here. And then these 2 moles of hydroxide were also kicked off and replaced with ammonia. Now, what is the name of this equation or reaction, I should say? It's a ligand substitution, okay? And you really need to know this. What is the color change going to be? What was the color change of our starting precipitate? Do you remember? Kind of cheated for you and wrote it out with the font color, but it's blue, okay? We've got a blue precipitate here. And what is our resultant complex going to be? What is the color here? It's a deep blue solution. Sort of throwing you off with the green here, but it's a deep blue solution. Now, what would we refer to this reaction as? Yes, it's a ligand substitution reaction, but we would not normally get this forming if it was a complete ligand substitution reaction. You would just get 6 ammonia ions, right? 6 ammonia ligands, I should say. Whereas this is referred to as incomplete ligand substitution, okay, or partial ligand substitution. I would stick with incomplete, but partial is also fine. Now, you also need to know what the ammonia acts as in this reaction, and it acts as a Lewis base. Okay, what is a Lewis base? It's an electron pair donor. So essentially, it's a ligand. You can think of it as a ligand, but it donates an electron pair onto the central copper 2+ and forms this aqueous complex. Right, our last base here that we need to react with, carbonates. Okay, so the 2+ ions are going to react slightly different to the 3+ ions in terms of the products. So let's look at the 2+ to begin with, and then we'll break down the 3+ ions separately afterwards and look at what observations and color changes you need to be aware of. Okay, so the first thing to remember here is when we're reacting it with carbonates with a 2+ metal ion, there's only 1 mole of carbonate required in the equation. And so that's just one thing to remember here. Slightly different to ammonia and hydroxide ions where you match the transition metal charge to the mole coefficient. We don't do that here. It's just 1 mole of carbonate ions, okay? CO3 2-. Now, the standard carbonate that you're going to see in questions is sodium carbonate, Na2CO3. That's the standard one you're going to be reacting with, but for the sake of the equations, just show the ion CO3 2-. So what's going to form here? We're going to go from an aqueous complex to a precipitate, okay? What precipitates are we forming for the 2+ ions? We're going to be forming a copper carbonate, okay? And this is a solid. And water molecules, okay? 6 of these guys are kicked off. And this is a liquid, okay? And I'm going to draw out the exact same thing for iron, okay? Iron carbonate, real easy stuff here, guys. Solid plus 6H2O. Now, I haven't properly matched the colors to the ink color of my pen here, but hopefully it's going to be completely fine for you guys. Copper carbonate, what color is this precipitate? It is a blue-green color. Okay, blue-green precipitate. So very similar, we're going from an aqueous solution, which is, what was this? You guys remember what this was? Blue, okay, blue to a blue-green precipitate, okay? Now, what was our iron 2+ solution starting color? Do you remember? It was green, okay? So we're going from a green solution. What precipitate do we have here for the FeCO3? Green, okay, real easy one. So I suppose when in doubt with iron 2+, you can kind of just put green on the page and hope for the best. But just keep in mind that you have to say whether it's a solution or a precipitate, otherwise you will not get the mark, okay? So what are these reactions referred to? You do need to know this, okay? These are called precipitation reactions. Okay, so let's move on to the 3+ ions. How do these differ? Just do your best to remember that for the 3+ ions, these are not formed, okay? The solid metal carbonate is not formed, okay? We get a different product here, so let's go through these right now. Okay, so I've drawn out our starting hexa-aqua complexes for our 3+ metal ions. Really important stuff here you need to keep in mind. The mole coefficients completely switch up, okay? So you always need to put 2 in front of these starting complexes for the 3+ reactions with carbonates. And our carbonate ion is no longer 1 mole, okay? We need to react it with 3 moles right here. CO3 2-, 3 moles of that. This is aqueous, remember? And exactly the same thing for our aluminium 3 plus. Okay, and we're going to get 3 products formed here. So hopefully I have space for this. The first product here is going to be exactly the same as the products we formed when we were dealing with reacting with a limited amount or just simply sodium hydroxide and ammonia. Okay, so it's going to be H2O3 OH3. Okay, and this is a solid precipitate. Now we're also going to do exactly the same thing for aluminium, H2O3 OH3. Okay, now you need to know the color changes that are occurring here. You also need to know a secondary observation that is really important to remember. What is that going to be? It's going to be the other product that is formed. Okay, what is that product? Some of you may already know. Based on the fact that we have a missing carbon here and an oxygen, it's going to be CO2. Okay, we get 3 moles of CO2 forming. What is the state of this? CO2 is obviously a gas, right? And you're going to get effervescence forming here. So I'll write that out in a second. Let's complete this one. Not sure what happened to the 3 there. 3 CO2 gas. And we also have water forming, okay? 3 moles of water. Let's draw that underneath. All right, so we've written out our equations in full. I left off the solid state sign there, so let me put that there, state symbol. What are our color changes? Do you remember what iron 3 plus started as? It was purple, okay, purple or violet solution. All right, and what are we forming here? Brown precipitate. Okay, exactly the same as the hydroxide and ammonium precipitate formed. So brown precipitate. Okay. Now, do you remember the aluminium and the aluminium precipitate that forms? Colorless solution. Hopefully you guys remember that. And we actually write down solution here and solution here. And this is a white precipitate. White precipitate. Okay, cool. Now, as I mentioned, we have a secondary observation here. Effervescence. Okay, this carbon dioxide is going to bubble up through the solution and we're going to get effervescence. So effervescence. Run out of space, but hopefully that's all good there. Effervescence. Really try to remember this for these 3 plus reactions with carbonates. All right, guys, so that's all the observations and equations you need to know. But this is a perfect opportunity to use some active recall. Take what you just learned, rack your brain, and apply it to 3 very simple questions here just to test yourself, just to get some good revision in. So question 1, what is the observation when you react an aqueous aluminium 3 complex with sodium hydroxide? Question 2, what is the equation for when you react an aqueous iron 3 complex with a carbonate solution? And what is the color change and the equation for when you react copper 2 and its precipitate with excess NH3? Okay, observation here. What was our aluminium 3 complex starting color and state? It was a colorless solution. And what is our product? What is our precipitate formed? It's going to be a white precipitate, okay? All right. Now, for this answer here, I would simply just say a white precipitate is formed, or you can say colorless solution forms white precipitate, something along those lines. That will be completely fine. But I would simply say white precipitate formed or produced, something along those lines. Now, you may be thinking, this is unfair. He didn't say whether it's a limited or excess amount of sodium hydroxide. As I mentioned, guys, AQA is not always going to specify that it's limiting, okay? As long as they don't say excess, assume that it's limited, all right? And just remember those equations. All right, question 2, what did you get here? All right, this is our equation here. 2 moles of this hexa-aqua iron 3 plus complex, 3 moles of carbonate ions forms this precipitate right here, 3 moles of carbon dioxide gas, and 3 moles of water. I didn't ask for the observation, just the equation here. Just really keep in mind these moles that pop up. Okay, so 2 moles of the complex, 3 moles of the carbonate, 2 moles of the precipitate, 3 moles of the carbon dioxide, and then 3 moles of water. Okay, try and remember that and you'll be completely fine. So last one then, question 3, color change and equation this time for copper 2+ with excess ammonia. All right, so I've written out the equation here, guys. 4 moles of NH3. This is the excess equation you need to remember. And we're starting with our precipitate, okay? We're not starting with our hexaaqua complex. We're starting with our precipitate right here, a solid, and we're forming this complex right here, okay? So what is our observation? What is our color change going to be? Do you remember what this precipitate color was? Real easy one, blue, okay? Blue precipitate. And what is the color of our solution? Is it simply blue solution? No, deep blue or dark blue solution. Okay, just remember that and you'll be completely fine. So with that, guys, that's the end of the video. Keep revising, memorize the color changes and the equations. Hopefully it's not too difficult for you guys. If you learned something, if you found this video helpful and you want to see more content just like this, like the video, it really helps the channel grow. Best of luck with your revision and upcoming exams, guys. Until next time, peace.